I'll start with a set of rules for writing definitions, which we've been calling Aristotelian definitions or two-part definitions. Traditionally, they were often referred to as definitions via genus and specific difference. And what this means is that if you want to define a term in an ontology, then you look for the parent term and you try and specify what the specific difference is, which means what it is about the instances of the child term which makes them different from the other instances of the parent term. So what this implies is that to make a definition you always have to specify the genus, which means the parent term, roughly speaking. And this fact, and I think it's a fact which is quite generally recognized, it's not only in BFO circles where we use Aristotelian definitions. All ontologies use something like Aristotelian definitions sometimes, some of them more systematically, some of them less systematically. But it's a characteristic of ontology land that people make definitions which cohere with the ontology and therefore which are going to be somewhat Aristotelian. Now the reason why I go into this account of definitions is because it's because of this fact about definitions that we need top-level ontologies. Because if every term is defined in terms of its genus, then the genus too has to be defined in terms of its genus, it has to be defined in terms of its genus, and eventually we would have infinitely long taxonomies, which would never end. And so there have to be some terms which are called top-level terms which do not have definitions. And they are called primitive or undefined terms. And Aristotle already saw that you couldn't have definitions for all the terms because otherwise definition would be a never-ending process. And this was formulated in the Middle Ages in a quite beautiful passage which I will not read by Bonaventure, which you find here. And so now there are three principal candidate upper ontologies. If you go to Wikipedia and you look for upper ontology, you will find, I don't know, 67 upper ontologies, most of which are not upper ontologies at all, in the sense I just explained, namely ontologies which are top level because of this problem with definitions and with the finiteness of taxonomies. So the three principal candidate upper ontologies in that sense are these. And we'll start with sumo. Sumo arose out of a quite important venture, I guess in the 1990s, to create an ontology which would be the merger of good ontology content from different schools. And some of my work is in fact incorporated into sumo. So the discussion of boundaries and topology in sumo, part of it comes from me. But it comes from other groups too. But for some years now it's been maintained by just one small group, which is led by Adam Pease, who is basically now the architect and manager of sumo. And sumo has a number of features which distinguish it from BFO and from Dolce, which is the third candidate. It's much bigger, so it has 1,000 terms, where BFO has 36 terms. I think Dolce has 40 something. It's also associated with various domain ontologies which are bigger still, but that's fine because the whole point of having a top-level ontology is that you associate it with many domain ontologies covering specific domains. And but the reason why sumo is so big is because one principal feature of sumo is that it incorporates the structure of something called WordNet. Now, WordNet is a computational lexicon. So, in other words, it's a very big dictionary which is managed computationally. And it's a dictionary which manages the English language. There are now WordNets in many other languages, but the original WordNet was English, and it contains very, very many words in the English language. Now, as we all know, the English language is full of ambiguities. And so WordNet organizes the English language in terms of what it calls synsets. S-Y-N for synonymy sets. And a synset will contain a number of words, all of which have the same meaning. And then a word in a synset may appear in another synset. So the word bank will appear in a synset with other words for financial institutions, and also in a synset with other words for parts of rivers or benches. And so it's useful to have an ontology framework, which is a formal framework in which the terms are defined and logically ordered, as a supplement to WordNet, because WordNet is messy in the way that natural language is messy, and an ontology like Sumo is not messy. And so that's the principal benefit of Sumo. And of course, once you have a mapping to English WordNet, then it's not too difficult to extend that mapping to all the other WordNets. For instance, the Afrikaans and the Albanian, the Arabic WordNets. And there are 2 Polish WordNets, which is not a good thing. But so if you go to the Sumo portal, which I gave in an earlier slide, here this is one doorway into the portal. You find the browser, and the browser shows you the real power. You can actually browse through different languages, so you can use Sumo as a gateway into all languages, really, which is an amazing achievement. So you enter your term here, you enter an English word in the box labeled English word, and then it will point to the corresponding WordNet page, which will give you definitions and so on. We'll see that in a minute. Now, as I say, Sumo is associated with a number of mid-level and domain ontologies for hotels, geography. I believe bacteria are in there somewhere. So it's a very impressive, wide-ranging achievement. The top part of Sumo, which is the part we're interested in here, is organized as follows. And as you can see, there's a lot of mathematical terminology here. Now, in fact, the bulk of terms in Sumo, leaving aside hotels, which are in lower level ontologies, the bulk of the terms in Sumo are from mathematics. Now, BFO has practically no mathematical content. Dolce has practically no mathematical content. We see mathematics as being already a supermarket which is available. You don't need to build a new supermarket if you already have a supermarket. You create a boutique store for a certain purpose, and then you buy what you need from the supermarket. Sumo didn't do that. So we have down at the very bottom processes, objects, and qualities. They are, roughly speaking, the domain of BFO and Dolce. Everything else is mathematics. And that's how it looks if you add the lower level ontologies. This is what the browser looks when you first go in there. So you can see mappings to WordNet and so on. You see pointers to all of the domain ontologies. And this is the structure insofar as it overlaps with the kinds of terms which you find in BFO and Dolce. So at the very top we have the physical realm, and then the abstract realm is where all the mathematics goes. So we have physical, which is the BFO Dolce kind of domain, and then we have mathematics, which go for Sumo under the heading of abstract. And we're interested in the physical. And this is how it looks. So as you see, Sumo very quickly moves away from the goals of BFO and Dolce. The goals of BFO and Dolce are to be very general: object, process, relation, quality. But here we have things like poking and manufacture and making. And these are not terms which one would intuitively think belong to this higher level area, which was set aside by Aristotle under the heading of categories. Aristotle had 10 categories. Top level ontologies are really theories of categories in Aristotle's sense. So that's my first worry with Sumo. It slides into the domain ontology level where it shouldn't. And similarly with the in the object realm, so poking and making and manufacture are under process. Corpuscular object, food. These are terms which do not sound to me as if they should belong in a top-level ontology. Moreover, it seems to me, and this is the problem we faced earlier today with the word pet. Pet is not a kind of animal, and food is not a kind of object. And so, but let's look at the definitions. So, a corpuscular object is defined by Sumo in this way, and the parent terms are physical object and self-connected object, and the child terms are organic object and artifact, and sibling terms are content-bearing object, which means something like an information entity, food, and substance. Now, this is not the way I would divide the world following the joints of reality. So a self-connected object whose parts are not shared by the... a self-connected object whose parts have properties that are not shared by the whole. And the substance, the definition is at the bottom. So I think definitions I'm allowed to read. It's an object in which every part is similar to every other in every relevant respect. So he means, by substance, I think something like water. But even water has parts, namely hydrogen atoms and oxygen atoms, which are certainly not similar to each other in every relevant respect. So we're facing problems here. These are problems which will arise immediately as soon as Sumo gets applied to physics or chemistry. Now, BFO doesn't face those problems, and Dolce doesn't face those problems. All right, now we have plants, various types of plants, and again, that seems to me to be inappropriate for a top-level ontology. Those things should go in the domain ontology. So we'll go through the advantages. It's a first-order logic ontology. There are representations in other languages, but it's first-order logic, which means that the axioms are axioms that logicians would be happy to work with, and that it's well architected. Because it's first-order logic, it's more intuitive than, for instance, OWL, which is not so human-friendly as first-order logic. There is a fourth ontology which I haven't mentioned called psych. Sumo is much more coherent than psych. We don't need to talk about the hardwired ontology in OWL, but someone talked about thing as the top-level term. I think it was in the Giotto. Yeah. So thing comes from OWL. Thing and nothing are the two main hardwired terms in OWL. But it provides a fantastically useful interface with WordNet, and I think that achievement it cannot be emphasized too much. Now, as I say, as soon as you start using sumo with domain ontologies developed by scientists, you get problems. So no scientist would ever define protein in the way that sumo does. No biologist would ever use the word crustacean as a technical term. And certainly no biologist would ever define a term called fruit or vegetable. So, Dolce. So BFO actually, in a sense, grew out of Dolce. So I encountered Dolce in around 1996. I worked for a time with the creators of Dolce. I still have phenomenal respect for the creators of Dolce. They really did invent most of the infrastructure of modern day ontology research. They had the first research institute for ontology. They had the first journal and first conference and so on. Dolce is a conceptualist ontology. That is to say, it's not trying to represent reality, it's trying to represent human language, human thought, human demarcations in reality. So it doesn't really have such a problem dealing with fictional entities or myth or possible entities. So the chief architect and designer and creator of Dolce is a man called Nicola Guarino, and whenever I talk to him, I always like to find out about how his 14th and his 15th and his 16th children are doing. Because for him, they are first-class objects, along with the 17th and the 18th and the 19th children. He doesn't have any children, really. So categories in BFO are highest level universals in a representation of reality. Categories in Dolce are just very, very general concepts. And whatever the more general concept under which unicorn falls, it would be in Dolce without any problem. The fact that there are no unicorns is not a problem for Dolce. And then it has axioms and relations. So it's organized architecturally in roughly the same way that BFO is organized. So this is the basic taxonomy. We call them continuance. Dolce calls them endurance. We call them occurrence. Dolce calls them perdurance. And otherwise, there are obvious similarities. Dolce has an ontology of states. That might be interesting from your point of view. But it makes states just static processes. Think about it. Then it's been inspired by linguists, and linguists have made a distinction between achievements and accomplishments, which is part of a wider distinction between different kinds of verbs. So if I'm going for a walk, then when I've finished my walk, I have achieved and accomplished something. But if I'm just walking, I'm doing neither of those things. Now that distinction is central to the Dolce architecture. And I think that although it's getting a little bit too near to language and linguistics for top-level ontology purposes, it's still an approach which is acceptable in a top-level ontology. And then we have a theory of locations, which is just the same as the BFO one, at this level anyway. And then we have a box of things called abstract, all of which are quality regions. This is the area of Dolce where it differs most from BFO, but this is also the area where BFO probably needs to, in the future, to work out its own position. So BFO has qualities, but it doesn't have the range of color qualities. It has individual color qualities, but it doesn't have a way of treating the quality range, and that is core in the Dolce approach. So this is this is a philosophical part of Dolce, which I'm not very happy with. So Dolce was originally inspired by Vienna Circle logical positivism, and more particularly by phenomenalism, which is a philosophical theory according to which everything in the universe is a sense datum. So a red patch, a red sensory item. And then if you put together a hard sensory item and here, and a hard sensory item there, and a hard sensory item there, and you do that a lot, you get a table or a desk. And then you add an orange sensory item, and then you get a table painted orange. And everything is just either a hard sensory item or some logical complex. So not everything is just a sensory item, a sense datum, or it's a more or less complex logical complex of sensory items. So the whole of the Renaissance is a gigantic complex of sequences of sensory items. So that's the basis of Dolce. I find that absolutely crazy, of course, because it is crazy, but it's a well-established way of being crazy with a long philosophical tradition. So physical processes are spatio-temporal distributions of qualities. What that means is that they are complexes of sense data. And and this is the story about how we get desks and unicorns and culture out of this sensory cloud. Yes?
You also said they are influenced by scientific positivism.
Logical positivism is not science. They thought they were doing science. Some of them were doing science, but phenomenalism, which is one version of logical positivism, is not a scientific theory. It's a philosophical theory. So Guarino was an engineer, and he imputes to me having converted him into someone who might better be described as a philosopher, and I feel very guilty about that. And he probably did the opposite to me. He converted me from being a philosopher to being an engineer, which I'm very proud of. All right, now, but then on the one hand, Dolce claims to be close to common sense, but on the other hand, they have this very non-commonsensical phenomenalist infrastructure. So Dolce and BFO differ also in the sense that BFO, at least for continuance, tries to be what we might think of as a single level ontology. So I am an organism, I am an animal, I am a complex collection of cells, I am a complex collection of molecules, I am a complex collection of atoms, and all of those things are me, just one me. I'm a person, I'm a philosopher, it's all one me. Where for Dolce, there are levels, and this is supervenience in the philosophical sense. So they have a concertina approach to reality. Now, this is useful if you're thinking about symphony orchestras. So if the symphony orchestra consists of 11 players who happen to be a football team during the afternoon, then BFO has a problem, where Dolce can just say, well, the same group of human beings is supervened upon or constitutes a soccer team and an orchestra. They are three different entities, where for BFO we don't have this constitutional trick. For BFO, constitution is identity. Now, the way we deal with it is in terms of roles and time. And so this is just some examples of how the constitutional talk works. This is a picture of how Dolce treats qualities and quality spaces. So we have red 421 is what they call a quale of the color of this rose, and it is an instance of a certain region within the quality space called color space, and so on. So
are those instances supposed to be like the basic sensory data, or is it something?
So these over here are the basic sensory data. This is just linguistic. So the fact that this is a red rose is just a quality attribution. That this is a red object is just a quality attribution, where for BFO this is the real thing. And well, the distinction between abstract and concrete is that for Dolce they have all of these mathematical things. They have Platonic propositions, which are the meanings of sentences. They have the quality spaces, which are abstract. So if BFO has in the future a quality space for color, it will not be something abstract. It will be something concrete, something visible, something I guess it will not be made of molecules, but qualities in BFO are not made of molecules anyway. All right, so we have two kinds of endurance in Dolce as in BFO, and it's more or less the same thing. So we have the physical ones, material entities, baseballs, planets, people, and then we have the non-physical ones, which are spatial locations. They think of mental entities as being non-physical, and that I think that BFO is neutral as concerns things like thoughts. But BFO thinks that the mind is a part of the body. We don't say that it's identical with the brain, but we do say that it's a part of the body. Or rather, to be more precise, when we talk to anatomists, then since BFO does not have a theory of mind or the mental, that belongs to a lower level ontology. When we talk to anatomists or to people working on the psychiatric diseases or on emotions, then the way we classify mental processes, for instance, is to say that they are a special kind of bodily process, namely one involving the mental architecture of the brain, which is part of the physical architecture of the brain. And then they have things like companies and institutions, which they call agentive, non-physical endurance, and laws and poetry, which are non-agentive continuance. We differ in this. We think companies are material entities because they have people as parts. But there's you can see that there's a very close similarity between the kinds of things which Dolce deals with and the kinds of things which BFO deals with. And so Dolce has some of the same advantages as Sumo. It's more coherent than Psych. It also has a gateway to WordNet. It's not as refined as the Sumo gateway to WordNet, but there is a gateway from Dolce to WordNet. We are working on a gateway of this sort for BFO. And it was formulated originally in first order logic. Most of its users use first order logic, but there are OWL versions of Dolce. And now the problems with Dolce are, first of all, it isn't really sure whether it's about reality or about concepts. So it's trying to have its cake and eat it, but I think it's just not sure. It's confused. I believe that there would be a proper ontological treatment of concepts, but that would belong to the ontology of psychology or the ontology of linguistics rather than to the world. And I'm not sure what I meant by the final sentence anymore. Oh, yes, I know what I mean. So the proper treatment of concepts should not be part of the ontology of the real world, where for Dolce it is part of the ontology of the real world, and that seems to be a mistake. All right, now we come to BFO, and BFO is based on these three dichotomies, and it's meant to be representing reality. It's focused on science. So all of the original work in BFO was done to support scientists, primarily biologists. We're gradually moving into other areas. Dolce was based on linguistics. So really the many of the principal inputs into Dolce came from the linguistic side and from this phenomenalism determining the general architecture. And the idea is that science does experiments yield data is about something. BFO is about the somethings which we have data about. It's a representation of the things we have data about. We don't have data about numbers or abelian groups in the way that we have data about cells and diseases and plants. And so that explains why BFO is focused very much on the concrete rather than on the abstract. So we divide the world into continuance and occurrence. This is an absolute division. Nothing is allowed to cross this division. This can be painful, but no pain, no gain is our motto. So you constrain the freedom of choice of people in making definitions in ways which they accept, and then you get more interoperability between all those groups who accept those constraints. And we have hundreds of people and hundreds of groups who are using BFO, so we seem to be doing something right. Okay, that's a picture of everything in BFO, actually. And then we created the Oboe Foundry by taking the architecture of BFO, which is along the top, and then levels of granularity, which are along the vertical axis, and then we identified ontologies, which had already been created within the BFO way of looking at the world, primarily because they were created around the gene ontology, which itself influenced BFO. And so this is the view of qualities which is defended by BFO, and I can present it as follows. So you see an eye. You're doing a phenotype of flies. You see a fly with an eye which is red. And so you've seen an individual instance of redness. This is what philosophers call tropes, or individual accidents, individual moments. So you see an instance of redness. That's an instance of a certain quality universal or type. And in this case, the quality in question is red. So red, in BFO terms, represents a quality universal. And we also use redness. Red and redness, for this purpose, is synonymous. So the eye is not that which instantiates the color. Rather, the eye exemplifies the color. And we'll come to that relation later on. And then Pato is a representation of all of these quality types. And now, the reason why BFO might need quality spaces or quality ranges, I think we're going to call them, which are analogous in some ways to the Dolce quality spaces, is because we can have motion. When the tomato ripens, it moves through the range from green to red. And if we don't have the range, then we can't deal with that kind of motion. And this motion applies to many kinds of qualities. Temperature, for instance, is a medically very important example of a quality range. Now, you remember qualities are dependent entities, and the idea of BFO is that we integrate data across many domains, such as plant biology and genomics, many species, so many different species of plants and bacteria which grow on plants, across levels of granularity, which you've seen already, across different perspectives, so we can have a physical perspective and a biological perspective on the same bacterium, for instance. And also across perspectives as concerns the viewer. So a sign is what is a marker of a medical problem as seen by a doctor, and a symptom is a marker of a medical problem as seen by the patient. So exhaustion or depression or pain are all subjective. You can only experience them as the patient, not as the doctor. And so BFO was a multi-perspectival ontology. That was the way we used to talk about it. But all the perspectives use the same ontology. That's the idea. Whether they are at the level of granularity of galaxies or at the level of granularity of molecules, they're all going to use the same perspective-free, species-free, domain-neutral ontology. And then we realized that we have to distinguish between qualities and measurements of qualities. So temperature is one thing. The result of measuring a temperature is another thing, and we have to understand the relations between those two. And that's a mistake that Pato makes. It does not clearly distinguish between qualities and measurements of qualities. So to be average is not a quality, and to be elevated is not a quality. All right, then we have the hub and spoke strategy, and we have various ontology suites which use BFO as a hub. We have lots of individual ontologies which use BFO as a hub. We have a textbook, and we have the Common Core ontologies here in Buffalo. We have applications of BFO in systems engineering, and we have various other test beds of BFO, and now these are the criteria that you should use if you're wanting to choose a top-level ontology. And I'm not going to read it all, but it should be well formalized, easily extendable to domain ontologies. Easily means painlessly, that you will find users willing to use your ontology. Now, I think Dolce has found a number of very clever people who have used Dolce in their work, but they haven't built ontologies for specific domains in the same kind of systematic way that is the case with Buffalo. And what I mean is experts, scientific experts, take BFO and build ontologies around it. In the Sumo case, most of the domain ontologies were built by the architects of Sumo, not by experts in the relevant domains. And that is a problem, because then people don't use them, because they're not accredited by and built to the specifications that experts would expect to be met.